morning, everybody. My name is Bilal Aslam. And actually, I want to preface by saying that I was asked to do a talk on what's new at Databricks. I actually think that's a really tall order. There is so much new at Databricks. I can't actually cover everything. And that's not hubris. I'm not exaggerating. I actually have a hard time tracking everything that's coming out. There's a bunch of new things coming out. So what I wanted to do was I'm actually going to take a step back and talk a little bit about why we're all here, what we're trying to do. We talk a lot about solving the world's toughest problems with data. I think it helps to take a step back and look at that. Everybody in this room is actually doing that. And then, of course, I will cover some of my favorite things that are coming out of Databricks. But there's a lot I can't talk about, but there are a few things I want to highlight. Very quickly, a little bit about me. My name is Bilal. I am the Director of Product Management. I run the Databricks product team, the product management team in Amsterdam. As Susie mentioned, the company has grown a lot. The office has grown a lot, actually, since I joined. I was, I think, person number 35. Now we're at 65 or 66 people, so that's great. About me, I was very lucky to work on this little cloud called Azure very early on. If you ever use the Azure Marketplace, I started that. It's a massive marketplace now since I left. After Microsoft, I started a company in the big data and machine learning space called Apuri, which was acquired by an e-signing leader called DocuSign in Seattle and San Francisco back in 2017. I've worked with Databricks for years. And that was one of the companies that I always thought, I actually wanted to be part of this journey one day. I'm very lucky to be here. Enough about me. I am hiring product managers, so if you are a product manager who's interested in being part of Databricks, who just wants to learn more about that, please just come say hello to me, or here's my email address. Always happy to talk. And that's a little photo of a team that's much, much bigger now. OK, perfect. So let's talk a little bit about tough problems and data. I've been doing data, machine learning, deep learning for many years now, just like many of you. And there's a narrative that solving these tough problems requires data. If you pick up Forbes, oh, this is magical. It just moved. I did not do that. OK. OK, all right, that's odd. I wonder if this motion sensing. So AI can go wrong sometimes. So there's a narrative that solving the toughest problems with data just requires, just add data and you get value. We all know that's not actually true. We know the promise is real, but we know the journey is very long. I've seen this again and again. If you sit in a boardroom, if you sit in front of a customer, and you know this too, this story often goes, well, we need data science and machine learning. We need BI. We need analytics. It will solve the problem. That's actually true. It will solve a lot of our problems. But we all know that most organizations, in fact, if not all organizations, really struggle to solve these problems. This is really, really hard work. And there are three kinds of silos that I've seen and you've all seen. There are data silos, there are tech silos, and there are people silos. In many ways, we're all here because these are real problems to go solve. The real world of what data looks like, and to get to that value, and I love the little video clip that Walter showed where I think a gentleman from Microsoft was saying, we need to solve business problems. Well, that's what it takes to get there. You have to start at the bottom. You have streaming data. You have data lakes. You have NoSQL. And by the way, this picture is by no means complete. If you really want to, and I'm sure many of you have seen this, there's a big infographic with logos. I think it's about 3,000 logos of different data platforms. There's one for marketing. There's one for CRM, and there's one for data platforms. There are thousands of logos on this, and it's sort of subdivided into different categories. All of that is real. All of that exists in the real world. And you need to do all of this. You have to, and we've taken some liberties with this. We've exaggerated sort of the complexity, but this is all real. You have various processing frameworks. You have validation. You may have TensorFlow thrown in. You need to track your experiments. You need to track your models, blah, 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 all of this. It's a mess. And the funny thing is, each of these products individually is great. PyTorch is a phenomenal framework. Looker, as you'll see soon, I think they're here tomorrow. It's a phenomenal tool. Google, all these clouds are great. They're all getting better and better. But to get to business value is a long journey. So why do businesses fail to unlock value? Well, one key thing, and I've seen this again and again, and you've seen this too, is data quality and reliability. It's a fact of life that most businesses have multiple copies of their data. They're sitting around, they're built by different teams, pipelines are unreliable. I've woken up more times than I can remember at 2 in the morning, data pipeline failed. I did a data and machine learning startup. It happened to me many times. So that's one problem. Well, the other one is disparate technologies, right? There's, how do you make TensorFlow work in a distributed manner? How does that work? How do you get your data lake to operate with all the other technologies you're using? It's hard. So lots of stitching together different frameworks. And then lastly, and this is a big one, actually, if you sell to an enterprise, if you are an enterprise, how do you manage data security? There's a new item about data leaks every day, it seems like it. How do you make sure that the right data is in the hands of the right people, the right controls are in place, and oh, by the way, you have an SLA to uphold. I've talked to a lot of customers who say, I'm responsible for getting insights to my customers, my internal customers. I have a 2-hour SLA. Increasingly, I'm hearing about 5-minute SLAs. So how do you manage that? How do you make it happen? So that's the reality. These are some of the reasons why businesses and organizations fail to unlock. So a little bit about Databricks. I know you've used the product. I saw a lot of raised hands, but I'll just go over what we do again. So one of the key values that we bring to the table, and we're going to keep innovating on this, is what we're calling our unified data service. And very simply, this means that a core piece of the platform provides you great data quality with great performance, no compromise, okay? And all of this sits on top of your existing data lake, whether that's AWS, S3, ADLS on Azure. You use your cloud, we build the platform on top of that. The next one is, I talked about people silos and organizational silos. So we provide hosted notebooks and MLFlow to allow your people to collaborate. And that's really important, because if you have the best data but people can't work on it, if they can't collaborate on it together, you're going nowhere fast. And I'll talk about some of the innovations there. And as I mentioned earlier, BI is increasingly important. Analytics is an existing way to get value out of your data. So we provide integrations with Tableau, Qlik, Power BI, and Looker, so you can access all your data. And one last thing, one thing we're very serious about. Yes?
I have one question.
Yes, sir.
I also would like to share this with some of my colleagues. Are you going to share this presentation?
I believe so. Walter?
Yes, so the presentation is being recorded, and if all the speakers are okay with that, I'm happy to share the slides afterwards.
Yep, of course. And one last thing. Something that we take very seriously is enterprise cloud service. This is the end-to-end security, end-to-end SLA management, and administration. As you deploy into an organization, let's say even with 2 business units, they often have different security requirements, different SLA needs, different management requirements. So everything from enterprise security to simple administration to production scale, making it work at scale. Okay, so this is sort of the preamble, and I'll get to the new stuff, what we're doing pretty soon, but thanks for bearing with this. So really, we're solving the problem, the world's toughest problems with data, AI, and people with our platform. Okay, so let's talk a little bit about Delta Lake. There's a lot of great stuff at Databricks. This is actually one of my favorite. In fact, Delta Lake is my favorite technology at Databricks. By the way, with a just quick show of hands, who here uses Delta Lake? Okay, great. So that's fine. I will actually go over what Delta Lake is, and I'll go over some of the problems that I dealt with when I was building a very large data lake as part of my, several times. So this is a little busy, but I'll actually walk through this, and it's a reality. Again, I've seen this again and again. When you're trying to build a data lake that is scalable and meets business needs, quite often in the real world, architects converge on this sort of architecture. And it's the classic Lambda architecture. What does that mean? What that means is that, okay, on top, you may have streaming events coming in. They might be going to RabbitMQ. They might be going to Kafka. They might be going to some Azure Event Hub, some queuing service or some queuing system. And what you do is you say, okay, let's say you're an e-commerce company and you want to be able to do real-time recommendations. For example, I buy some clothes online. I'm very lazy. So as I browse the website and I'm looking at different things, you want to be able to give me sweatshirts that I like based on my last 5 clicks. So that means you need to take the click stream and process it in real time. So typically, what you'll do is you'll say, OK, I'm going to ingest the events into a system like Kafka. Then I'll have Spark streaming do something with them. Maybe do real-time recommendations, or maybe update some database. And streaming analytics, maybe I'm just showing the sales in real time. It doesn't really matter. So that's the top path, and that's how you go at the top. Then you'll say, well, I also have batch needs, so I need to be able to do historical analysis. And you'll say, great, I'm going to take my event stream over here, and I'm going to tee it. I'm going to tee it into a data lake, and I'm going to do processing on that. And that sounds OK, but now you start running into some pretty serious problems. Who here has dealt with small files in a data lake? It really sucks. It really sucks. So very quickly, the problem is that cloud object stores like S3 or ADLS, it's not a file system, even though it has some of the semantics of file system. So accessing small files, even listing small files, is very painful. It's very expensive. So suddenly you've littered your data lake with potentially millions or even billions of small files, and metadata about your data lake is now big data itself. So your queries start slowing down, and everything just sort of grinds to a halt. And you start doing all these odd things to try to update records. Remember, your data lake is also not a database. So now if you try to update and merge records, you're in trouble. Anybody who's used Hive here, for example, knows what I'm talking about. It's very, very slow. And now, oh, by the way, your business users are knocking on your door because they want batch reporting and they also want streaming analytics, right? So these infrastructures also require validation. So somewhere in there, you have to do data validation as the data comes in. So very quickly, you've walked away from you're kind of slowly crawling towards the promise of business value, but you're managing this monstrous infrastructure, which is really hard to deal with. And again, I've seen this again and again. I've actually built one of these. This was this is actually why I started talking to Databricks very early on. My company started writing a compactor for small files because we were dealing with small files. And I thought this is such a giant waste of time. We are not in the business of writing big data compactors. So along comes Delta Lake. And Delta Lake is an open format. So it's several things. But most importantly, it's an open format. You can go to delta.io today, and you can browse the documentation. You can browse the source code. And actually, one thing that I haven't called out about Delta Lake, it's a very fast-growing project. We have hundreds of contributors at this point, lots of great pull requests, and just great community adoption. So at this point, and this was not true 6 to 9 months ago, but now Delta Lake really is the standard for what I would call planet scale or internet scale data lakes. It really has great adoption at this point. And I think the open nature has a lot to do with it. So if you're interested in learning about it, if you want to contribute, please do. And you can talk to me or Tim Hunter. We'll be happy to talk about it. OK, but what is Delta Lake architecture? So this seems a lot simpler, and actually is a lot simpler than the previous architecture. So Delta provides several things. It's an open format. It's also an ACID transactional system. So you can now start treating your data lake like a database. And that's huge. So you can do updates. That's amazing. It did that. OK. I don't know why it does that. So you can do updates, you can do merges, and you can do deletes. And one of the amazing things about Delta Lake is that you no longer have to worry about the small files problem. Delta has a transaction log, and you can your metadata about the files. You can have billions of files in Delta Lake, and we use Spark infrastructure to process that metadata itself. So when you start treating your metadata like big data, and you deal with it in the way Spark deals with it, you no longer have to worry about maintaining all that Lambda infrastructure. So how does Delta Lake work? You still have your data sources on your left. You still have your Kafka, your Kinesis, your Azure Event Hub, and all that. Perhaps another Spark streaming output, right? But now, OK. Ooh, that changed completely. So I have a hypothesis. OK. So with Delta, it's all about changes. By the way, the word Delta, does anybody know why we call it a Delta Lake? OK. We call it Delta Lake because it's all about change capture. It's all about data capture. So the deltas are the small files, the small changes, and the small commits that you're capturing. And the platform, the way this works, this is a lot simpler now. You just ingest into a table. That's it. You just bring your data into a table. It doesn't matter if you're landing it every 1 second or every 10 seconds. You could be doing event at a time. Just bring it in. Just bring it into a table. And that's it. You don't need to have a T. You don't need to have one thing going here, one thing going here. Just insert it into a table. And then by the way, this is not the only architecture we'd recommend. It's the simplest and it's the most common. Now you just use SQL or Python or Scala to just filter and augment and clean your data. So take it from your raw table and you just insert into another table. That's it. It's very simple. And then you just run SQL again to get your business level aggregates. Now the great thing about this is that you actually have streaming data coming in, right? Yep. So as your data streams through the Delta Lake, you can build a very simple architecture. And really, this is as simple as just chaining up some SQL commands. Data can be low latency. It can be manually triggered, but it moves through your tables just like in a database. You don't have to think about this anymore. I want to touch on a couple of things real quick here. The ACID transaction is huge because you no longer have to worry about things in Hive, like did my data change? You just commit your data, just like in a database. So you stop worrying about failures and failed transactions and things like that. Just focus on data flow. Delta is built entirely on Apache Spark. It's a library. Go to delta.io. You can browse the code base. It's just built on top of Apache Spark. It's a set of libraries and technologies built on top. So by default, it unifies streaming and batch. You don't have to think about streaming as separate from batch. And then it really is trivial to convert your existing tables, your Parquet back tables, into Delta tables. It's literally one command. So if you're curious about this and you think, okay, maybe I could use this to simplify my data infrastructure, really, take a table and convert it. Try it out in your dog food or staging environment. It's really trivial. And even to this day, I think, God, I wish I had this 5 years ago. I spent so much time building this infrastructure. Okay, so as I mentioned earlier, one of the great things about Delta is that it allows you to treat this like a database. All the things you're used to, inserts, updates, deletes, merges. Why does that matter? GDPR, obviously really important. You want to comply with it. Previously with Databricks or any big data platform, if you want to delete a single record, how would you do that? Well, it often means rewriting an entire partition, right? With Delta, it's just a delete command. Go delete it. Just treat it like a database. If you have slowly changing dimensions and you want to capture those, you want to update a type 2 SCD table, how would you do that with Hive? It's very complicated. With Delta, it's just a merge or override, depending on what you're trying to do. So data correction, data retention, very easy. And one of the really great things about Delta, sort of like a hidden secret of Delta, is that it's just files on a file system, on a cloud file system. So if you want to back up your Delta tables, just copy them somewhere. That's it. Just do like a copy from one bucket to the other. That's it. It's very simple. So that's one of the beautiful things about Delta. It's simple. It just works with Spark, and you can use your existing tools. OK, so that's Delta. Absolutely one of my favorite technologies at Databricks. And one of the things that we're going to be investing heavier in the coming months is making querying on Delta, say from BI tools, much faster. So that's one of the things my teams, we work on in Amsterdam, and you should look forward to that. We've announced this as well. In the coming months, we'll make it easier and simpler to query Delta tables because we just have massive adoption. It's now the standard. And now that it's easy enough to bring data into Delta tables, everybody wants to connect BI tools to it. So that's going to get faster and easier. In the last couple of months, we've announced, if anybody has a hypothesis about what's going on here, please do tell me. I think it's like when I step back. Hand movement.
Is there a timing on the slides?
That would be the most logical, but I haven't set those up. I'm going to go see if that's the case. It could be that, actually. It's the most logical solution. Let me see. Okay. Are there any questions about Delta before I move forward? Yes.
A year ago, I looked at Delta, and it's a good product, but if you read the Parquet direct, I'm doing the whole GDPR. The data still exists, it's not really GDPR approved. If I get audit, I can still find the customer's data. It should be deleted. Is that still the case?
So let me, is your question,
I do Spark read Parquet, and I go direct to Parquet files.
Yep.
Not via Databricks, but direct.
Sure.
But I still find the data.
No. So in the GDPR case, we'll actually go overwrite that specific partition. And actually, that actually is a good thing. I forgot to mention this. One thing, who here knows about Z ordering? Okay, so Ernie uses Delta. So one of the great things about Delta is that Delta has support for something called Z-order. And Z-order is a way for us to co-locate rows together. And it's a little bit hard to explain, but basically, imagine if you had a very, very large fact table, billions, possibly tens of billions of records, and you wanted to do a point query on it. You wanted to say, okay, give me select from this table where, name is Bilal, right? And big data doesn't have indices. There's no such thing, right? So with Z ordering, certain types of queries, point queries, become very, very fast, and that's available with Delta. So we, for example, have customers who have incredibly large tables, tables that are actually not queryable using cloud data warehouses, that are not queryable using Hive, that are not queryable using, say, open source Spark. They can't query them. There's just too much data. And with Z-order, we are actually able to query those tables very quickly, Delta tables. So if that's something that's interesting, if you have a scenario where you're just ingesting, say, a massive amount of telemetry, maybe in QB's case, that would be interesting. And that's unique to Delta. That's something you should look into, and I'm happy to talk about it offline. Yes?
The question is also about deleting data. So if you have deleted something, vacuum should normally clean.
Yes.
Or there's a time defined for that cleaning.
Yes.
That when you set it to 0, it would delete it immediately. That's probably where the question is about.
Oh, I see. I see what you're saying. Yes. So there's a default retention period, or you can vacuum manually as well. Yeah, I'd be happy to share documentation with you on this. You're right, the underlying data store is Parquet, so the actual files are Parquet. But Delta maintains a commit log. So you can say, okay, if I'm in a GDPR scenario, exactly, you would go and vacuum immediately if that's the requirement, or maybe daily if you want to. In your question.
Yes, what does this bronze, silver, and gold mean?
Yeah.
Are they different tables, or is it one table
Yeah.
in different?
There are different tables. So this is a pattern. And the pattern is that there are different tables, and the idea here is that it's often the simplest thing to do from a data engineering perspective is to just insert the data into a table, just land it. You might be doing this already with a Parquet back table. Just add a partition, or just bring the data in. And the idea here is that the data moves from left to right between tables, and the tables get progressively better. And by the way, that's what we use internally at Databricks. We have massive fact tables of product usage and things like that. We just land the data into a single Delta table, and then we progressively make them better. And what this does is that if you screw something up over here, if you mess something up, let's say an augmentation was not correct. Let's say some data cleaning was not correct. You can always go back and backfill very easily. And Delta makes this very simple. Yeah, so you're still loading, you're still storing data in your S3 or Azure Data Lake, right? But the operations on these tables are a lot simpler. The inserts into those future, let's say you're mostly inserting into this table and occasionally deleting from it. So those are very cheap operations with Delta. And you can do them continuously. I think that's really important. You can do them continuously in a streaming fashion. Yes?
So you will receive unstructured data from
So it's your choice. So in our case, for example, internally in Databricks, we have structured and unstructured data coming in. So for example, we have data coming in from a CRM that's really structured. Then we have telemetry data, usage data coming in that's mostly unstructured. So these are just tables. So you could, for example, have a mix. You could say, okay, I have 50 columns that are structured. So a customer ID, a username, and then if it's an event, you could have a unstructured event in there. So you could mix them, actually. One thing that I see happening a lot is, that's actually a pattern that I see happening a lot, structured and unstructured mixed, and then you just clean it as you go. So for example, you may take your unstructured event and you may apply some normalization to it. And then it's replicated in a smaller, normalized fashion in a future table, in the bronze, in the silver or gold table. You can do both. Yeah. Yes.
Is there any infrastructure in Delta Lake for data provenance? Like, where is your data coming from? What happened to it?
Yes. It's something we're heavily thinking about. There is a sort of a weak form or a base form of it today. So but it's at the transaction level. So for example, if you do a commit to a Delta table, let's say you do a merge or a delete or an insert, each of those transactions is recorded. But that's not what you're talking about. You want actually provenance on, let's say, each individual column or cell in column. That's something we're thinking about. It's not there yet. Can you tell me a little bit about what you're trying to do?
No, well, nothing yet. It just seems like an interesting product.
Yes.
I'm wondering if this is built in.
Not yet.
So the Delta Lake is mentioned or is positioned as an alternative for storing data as a data lake store, or even Snowflake. Am I right with that? Or,
Yeah, so let me clarify something real quick. So Delta Lake sits on top of your Azure Data Lake, or it sits on top of S3. So Delta Lake doesn't work without a cloud. I mean, you can run it locally on your laptop just fine, but in production, you will run this on top of a cloud object store like Azure Data Lake. Now, your question was about data warehouses. Is Delta Lake a data warehouse? Look, Delta Lake is a phenomenal place to store very large amounts of data and query it really quickly. You can connect your existing BI tools to your cluster, query a data lake. You can run pretty much any BI query. You can run the full TP-CDS set on Delta Lake, for example. It fully supports that. And actually does a very good job. It's very fast. So I will actually ask you, I would go back and I would say, look, what are your scenarios? What are you trying to do with a cloud data warehouse? In many ways, Delta Lake, in fact, it is the new standard for BI and for large-scale data lakes. But I would go back to you and I'd say, what are you trying to do with a data warehouse? And I would ask that. I would go deeper into your question.
do we have to explain that now, or?
We can take it offline, if that's okay with you. That's a really good question. We have hundreds of customers who are using Delta Lake for BI and for data warehousing at this point. And it works very well. Yes?
Yes, just on that, I mean, this is like data warehouse architecture forever, right? So do you guys have support for conversion from Teradata and Netezza to the Delta Lake? So people already have big investments they want to do
Yep.
to the cloud, but they want to retain the data warehouse features that they have on premise.
Yeah.
How do you support that when there's a whole bunch of ETLs built up over 20 years?
Yeah, that's a really good question. So we're working closely with several partners to make migrations easier. And we're working with several partners to make ingestion into Data Lake much easier. There'll be announcements in the coming year on that note. But to your point, if you're using, you might be using Informatica, for example, to manage data with, in Netezza or Oracle. We're working closely with several partners. As was mentioned earlier, we have 450 plus partners, and some of those are very interested in helping make ingest into Delta Lake much simpler. So yes, one last question, then I'll have to move on.
Just one quick question.
Yes.
Using Databricks, just on the standard way, if we had to switch to Data Lake, what kind of licensing costs could I be thinking of percentage-wise?
So your question is, if I'm already using Databricks and I want to switch to Delta Lake. So there are two types of costs you should think about. One is a human cost, and one is a, let's say, machine and storage cost. The human cost is actually, for prototyping, is very low. So what I've done already by myself, I've taken I would take a Parquet back table that is, you can easily convert that into a Delta table. And everything that you do with the Parquet table will just work now as a Delta table. In terms of the storage cost and the machine cost, it's very comparable to what you might be doing already and potentially lower. So the metadata. No. So Delta Lake is included as part of the Databricks platform. I'll have to find out for you. I believe it's available on pretty much every cluster. This was not the case about a year and a half ago. It is now included as part of the platform. But I will find out for you. Okay, so I want to cover one more thing. My second most favorite new thing at Databricks. And by the way, there's a ton of new stuff coming out from MLFlow. Show of hands on who's using MLFlow. Ernie. Ernie gets the prize. Who here is building machine learning models in production? Let's go there. Perfect. And who is not building them in production but trying them out right now? Okay, so this is relevant then. And by the way, in my past life, one of my company also built machine learning models, and this is another product I really, really wish I had. So I want to talk about MLFlow, but some of the reasons behind why we built MLFlow. And if it's not, and it's not timing. It's not timing. We know that now. So ML development, just before I talk about MLFlow is also open source. It's another project that I think it's one of the fastest growing open source. It probably is the fastest open source project at Databricks and one of the fastest in the Python community. So if you're a Python developer and you want to contribute to this, please go look it up. It's open source. You can run this on your laptop or on your own server. So one of the things that I took away was that in my time building machine learning models was that in many ways machine learning development is far harder than traditional software development. And why is that? Let's compare the two. So with traditional software, you have product managers like me who write a functional specification, and then you basically converge to that. You have to build to that. In machine learning, there's no such thing. There is a business goal, but you're typically optimizing a metric of some kind. It's my gestures. You're optimizing a metric of some kind, such as accuracy or F1, whatever, and you're continuously improving it. Whether that continuous is every minute, every hour, every week, it doesn't matter. A lot harder. In traditional software, by and large, quality depends on the code and how you test it. In machine learning, the quality depends on your input data, your tuning parameters, the algorithm you chose, and actually changes to the underlying data as well. And in traditional software, you typically pick one stack, whether you're a JVM shop or a .NET shop. Sometimes you mix JavaScript and things like that, but it's one or two stacks. And in machine learning, and this is going to be true for a very long time, if not forever, you're really comparing and combining many different libraries. You might be using scikit-learn, pandas, NumPy, TensorFlow, PyTorch. It's just a reality of machine learning. And getting your models to production is even harder. And this is a cycle that I've seen again and again and again. You have multiple roles, multiple people in the company who participate in getting a model into production. And by the way, this is excluding any business user, right? This is just on the sort of the fingers on keyboard, people who make it go into production. So you have data engineers who are preparing the data. They might use tools like Pandas, Spark, R. You have machine learning engineers who are actually fingers on keyboard building the model, who are trying out different layers, who are trying out different logistic regression versus gradient boosted trees. And then you have deployment. You actually have maybe DevOps or machine learning operations who's deploying the model to production. And these people, they might be deploying TensorFlow edge models. They might be deploying to Docker. They might be deploying to Kubernetes, right? And oh, by the way, you have raw data coming into this cycle all the time. Your machine learning application must be kept up to date. It's just, it's complicated. There are a lot of chefs in this kitchen. So what does the industry do? The industry has machine learning platforms. We've seen this again and again. At Uber, there's Michelangelo. At Google, there's TFX. And at Facebook, there's a platform called FB Learner. And these are solving problems for these big companies who can invest resources in these platforms, make it happen. Not all of us can do that. So that's why we created MLFlow. It's an open source ML platform, kind of going where Databricks' philosophy of being open and community driven. And the philosophy behind MLFlow is that it works with any ML library. It works with any programming language, and it works with any deployment tool. And the goal is to make your machine learning operations simple, fast, and reproducible. It consists of 3 components. Actually, there's a 4th one now that's not mentioned here. It consists of tracking, so you can do your machine learning experiments and track them. That's important. When my company was doing machine learning experiments, we had 5 different data scientists doing the experiments, and they were working on the same thing. They wouldn't always talk to each other. So experiment tracking in a centralized place. Projects let you package up your runs into something reproducible. So it's one command, run it, and it works. And models are about model packaging. So you can package up your model. And as I mentioned earlier, this is great. At this point, this is actually slightly stale. We have 140 contributors. We have more now. And 800,000 downloads per month. That's really amazing. So MLFlow is a rocket ship that's taken off and really started to become, like Delta is the standard for data lakes, MLFlow is starting to become the standard for machine learning platforms. It's very exciting. So what is MLFlow tracking? Also called MLFlow tracking experiments. Very simply, you can run the MLFlow server yourself. If you're on Databricks, we provide it as a fully managed service. And MLFlow tracking server exposes an REST API. So from anywhere, you can log things like parameters and metrics. So if you're a data scientist, you're sitting on your laptop, you're experimenting with the model, you just use the MLFlow client library, and you can log your parameters, you can log your metrics, and it goes to the REST server, and it's persisted. Very simple. And all you have to do is wrap your existing experimentation code in an MLFlow call. Why is that important? It's because anybody can go in and now, anybody can now go in and look at what the team is doing. So if you have a team of even 1 data scientist or 2 data scientists, you can look at runs, you can inspect them, you can add notes, and this UI is getting better and better. But this is really about the promise of making your team collaborate, make your people better, work better. MLFlow projects are very exciting, and this is a challenge that I dealt with. I've seen customers struggle with this again and again. The question is like, hey, it works on my laptop, but how do I get it to work on someone else's laptop, and then in production, potentially? So MLFlow introduces a project spec, and this is very simple. The idea behind, who here uses Conda, for example? Anybody uses Conda? So you've dealt with this problem already, where specifying an environment, specifying what command to run, specifying how to test it. So MLFlow project specs let you package up the definition of a run and make it reproducible. And in a very similar vein, MLFlow model packaging lets you take your models and also define the model format. And this is a very simple thing. It sounds trivial, but it's really, really powerful because it's one layer of abstraction away from your tools, and it encapsulates all your tools. So now you can package up your model using MLFlow, and you can bring it to REST serving. You can push it out to Docker. You can push it out to SageMaker, and much, much more. So what's new? You may have heard all this already, but very recently we announced this. One of the things that we've been thinking a lot about is the model management problem. As your business scales out, as you start introducing more and more models into your company, this is literally what I think H5 is TensorFlow. This is what it looks like. You have multiple models sitting on your laptop, and I see some smiles, because that's actually how it is. You just serialize your models. You pickle them using whatever serialization format you use, and you just keep them in Git somewhere. And the problem is nobody knows what these models are. If somebody walks away from the company tomorrow, takes a vacation, it's a problem. So questions like, hey, where can I find the best version of this model? It's hard to answer that question. How was this model trained? That's sort of a provenance question. Hey, how did you come up with this model? What about documentation? We're used to that in software. You write Swagger API documentation. You may have it checked into Git somewhere. What about docs for the model itself? And can I review your model? Can I see what's going on? And these problems are basically unsolvable today, or were, even with MLFlow. So we're very happy to announce, we announced this at the Spark Summit Europe, we've announced the MLFlow model registry. And in the vein of MLFlow, this is all about making your team more efficient and providing a centralized place for operations on machine learning. MLFlow Model Registry is a repository of all the models. And it's a centralized place to track them and to track metadata about your models. For example, you can name your models, you can version them, and you can even add comments and tags. So for example, in this screenshot, you can see that here's a airline delay model, and there are multiple versions, the times they were registered, who created them, and you can even do things like you can track stages. So you can say, hey, this model is only for the staging environment, but here's the model for production. And you can easily point to a specific. You can easily say, and by the way, this is really cool. We do this. You can say, I want to get the production model for this environment, and it's all available automatically or in an automated fashion via the API. So here's the model registry workflow. Typically, a model developer will register a model with a model registry. Reviewers, for example, I could be a data science manager, I could be a practice lead. I can go look at the MLFlow registry UI. I can see what's going on. And my CI and CD tools can also work against the registry. So your CI tool can pull the model out of the registry, potentially run some tests on it, and so forth. And then the model registry becomes a centralized point where you can now push it to downstream users. You can push it to automated jobs. You can push it to SageMaker, for example. So very exciting. Again, it's one of those things I'm very excited about. I wish I had this when I was running my company.
So you basically say that you can manage your models with MLFlow, and then if you package your model, then you can also make it serve as a trigger for Azure DevOps, for example.
Yes, exactly. So you can exactly. Exactly, exactly. So going back to the promise of MLFlow, it is to make machine learning operations simple and reproducible and efficient. So it's all about providing a centralized place. I do want to mention MLFlow is an open source project. You can try it out now. If you use Databricks, it's also available. And I believe the model registry is not available on the platform to customers yet, but it will be soon. So very, very quickly, I started this conversation or this talk with sort of this big promise of solving the world's toughest problems. And I want to call out some customers who actually are solving some of the toughest problems with Databricks. So Regeneron, for example, is saving lives. They're doing some amazing work on creating medicine, a personalized medicine for chronic liver disease. Genomics is actually a massive vertical on Databricks. I believe we announced a new library and set of tools around genomics as well. And the sort of computations you have to do to make that happen, the scale at which you have to work is just phenomenal, and it's possible with Databricks. Personalized medicine, cancer drug discovery, disease data, these assays of genomic data are phenomenally large, very complex, and we make that actually possible to work with. Another company that I've actually worked with them prior to Databricks, FINRA. So in the United States, FINRA is responsible for combating financial fraud. And they work with massive amounts of data, literally trillions of data points on security exchanges and sales. Well, that's odd. And for example, graph visualization, cybersecurity, machine data, social data. They're making the financial world a safer place. And lastly, QB, Ernie's here. Some of our customers are helping conserve the planet, making energy use more efficient. Everything from smart cars to smart homes to IoT and video data. So I do believe we're getting closer to the promise, closer and closer to the promise of data. I'm excited to be here with you, and thank you for joining.